Okay, so the ones you've screened, how many articles did you finally include in your for the systematic review?
Okay, the ones that are qualified and met the criteria.
Yeah.
So I think I have 22 articles.
Okay. So we are going to start the data extraction for the 22 articles.
Okay, sir. So, sir, I don't know if you remember, in the last class, we were contemplating whether to change from the artificial intelligence, computer aided. Sir?
Yeah. I can remember that discussion.
Yeah.
So
Yeah. So I got only few articles for artificial intelligence. So I'm thinking maybe I should just change
go
it up
with the both of them.
computer aided so
Okay.
that
The
we
only
need to
thing,
cover
if you are going with the both of them, you just have to tweak your eligibility
location.
criteria. Yeah,
Yes.
those are.
Yes, sir.
Okay. Mm. So if you open up an MS Word first, because for the data extraction,
Yes.
I usually do it with a table. So I have what I call the table of study characteristics, just like in primary study, where you will have what's it even called in primary studies again? Like the baseline parameters
Okay, sir.
in your primary study, or characteristics of your population or participants. Yeah, characteristics of the participants. That's what you the similar one for primary study. After that, you now have your table of outcome. So, but let's start with the table of study characteristics first. In the MS Word, if you open the blank document, and then insert a table,
The dimensions,
you
sir.
can just you can just put any dimension. If we need more, we'll, I usually just click on insert table, and then
Okay.
yeah, mm, just say okay. We can update it if we need more columns and rows.
Okay, sir.
So the first column, I usually put like the what's it called? Um, trying to remember the study, or you can just write study, because that's where I usually put like the reference to the study, probably the first author and author and the year. And then if you press your enter key, just so you have space under, and then you can put location in bracket. The reason why I usually put the location is because, is this your, I'm trying to remember your title. Is it just Nigerian based study, or it's not for a particular
No, no,
country,
no,
is
no, no.
it?
It's not for a particular country. No.
Okay, yeah. So because of that, I usually have the location so that I can also indicate the different countries where those studies were done.
Okay, sir.
Then the next column is where I usually put my participant characteristics.
What, sir?
Participant characteristics.
Okay.
So later we may come back to that one and then put all the. Sorry, forgive me. I forgot that this is not. Even though they use adult, but we are looking at blood smears, right?
Yes.
Uh, were there any specific characteristics for the individuals they used?
No, there's no specific
Okay,
characteristics. Yes.
just a minute.
Okay, sir.
Sorry about that. Okay. The blood smears, were there any specific characteristics they were looking for in the blood smears?
Specific characteristics. Is it relating to the type of cells that are there, or the um, the subjects that the samples were collected from?
Yeah, like the subjects, are there
No, no,
things
no,
that they will be
no,
like,
no. Both adult and children.
okay.
Yes, sir.
And was there any age limitation?
No, sir. There
So
wasn't.
there were no age limitations.
Yes, sir.
And the only thing they needed was, did they have
No,
to test them to know that they have malaria parasites or
the thing is, they are trying to compare normal conventional microscopy to an AI
yeah,
method. So most times
yeah.
data they just get the slides now that is already done. Get, so they will now do the microscopy. But those slides, the sample that were used for preparing the slides were sample from patients that came to hospital. I don't know if you got what I'm
Did they
saying.
did they did they come to the hospital with symptoms of malaria or TB?
It's not compulsory they come with the symptoms.
Okay, okay.
Yes, yes. It's not compulsory. They
So
just test subjects to like compare the results that normal manual microscopy did to the one that AI or computer assisted did, to know the level of accuracy. Maybe the AI result is more accurate than the manual result.
okay.
Yes, sir.
So that means we don't need the participant characteristics if there was no specific characters they were looking for.
No, no.
For example, adults or males
Mm.
or females, and if there was no data telling us the number of males or females and all those things, then we don't need that. So if you clear that, and then maybe in that column we will now talk about and then you said there was no. Okay, so in that column just put the malaria blood smear.
Okay.
But in my previous work, because the physiotherapy or other studies I've done are related to, like, are mainly about people. So I used to have the participant characteristics where I talk
Okay.
about the age of the participants that were included in each of those primary studies, the number of females, the number of males, they are, depending on what I'm looking at, I may include the educational background, also include things like their attrition rate. Attrition
Okay.
rate is about like people that the number of persons that did not finish that dropped out from the study before the study was completed. Those little information like that. So in the other column, we may now have the TB blood smear.
No, that one is it's not blood. It's sputum.
Oh, sputum smear.
Okay.
Sorry,
TB.
sputum smear. Okay. Then um, we can put the outcome measure in that column, and then we can have the result. Okay, so let's go to the first study among the 22 included studies. So just from the name, data extraction, all you are doing is going into those individual study, getting
Okay.
the particular information you are looking for, and then putting
Okay.
them. Okay, so this is we can call this one. Can't pronounce this person's name. Moradia et al. 2024. So if we go back to if you copy this surname, the surname of the first author,
Which one is it? Okay.
yeah, under the title. Okay, if we go to the MS Word,
So I should paste it on that study.
yeah.
Okay. Eh,
So we only need the surname.
So the surname is.
Yeah, the one that started with M.
So I should remove the Roy.
Yeah, remove the first name,
Okay.
and then et al. After the surname. 2024. Okay. And let's check where the study was conducted. United States. We used the publicly available thin blood smear dataset from the United States National Library of Medicine. Okay. Can you go to that place they wrote the title of the work?
But I think it's in the US.
Okay.
Yes,
Yeah.
United States.
Most so US, that's the location.
So brackets US, abi?
Yeah.
Okay, so
I would usually like put the enter key just so it's another.
okay,
Yeah.
like this.
Yeah. Exactly. Okay. So where the place that heading, that column where we put the malaria blood smear, if you
Yes.
change it to blood smear use, so just remove the malaria.
Okay.
No, because the other one is Putu. So I would say type of smear rather
Type of
than
smear, abi?
because yeah, that would be more appropriate.
This one it was blood smear that
So
was.
yeah, they used blood smear.
Then the other column for TB sputum sprinkle.
We'll change that in a minute.
Okay.
So that work, was it just the malaria blood smear they did? They didn't look at
No, no,
TB.
no. Just malaria. Most of
Okay.
the articles, you see that it is only malaria or only TB.
Okay, none of them did for both.
No, no, there are some, but I'm not sure. I think there are some.
Okay.
Yes.
So let's go back to the article again. I want to see that method on the abstract.
Okay, this is the method.
Yeah, we use the publicly available. Okay, consisting of. Okay, we created 4 datasets containing images. Okay. So just for me to understand, this team blood smear, this data set, these are not like fresh blood. These are like information that are some stored somewhere already, right? In the uh, national something, because I know this NIH is
Yes, yes,
US
yes, it's
medical.
correct. You are correct. So
Okay.
the thing, this is what they do, sir. When they get these slides from hospitals, so then they store
Yeah.
it in all these libraries. But it is human sample they use them.
Okay. So the blood samples are still there
Yes, it is preserved.
on
So
the
in case
slide.
anybody
Yeah.
wants, yes, in case anybody wants to make use of it, they'll just get it and do
Okay.
whatever research they
Okay.
want to do on it.
Okay. So meaning that it would be wise for us to indicate the method they use in obtaining the smears they are using.
Yes, but it's not in all cases. There are some that
It-
they did it
They
like
just take from the
for people
patient.
that came from, yes, from the patients directly.
Yeah, so that's what I'm saying. So it is important for us to put in that table like the method.
Okay,
Is it like from taking from
oh,
stored
okay, sir.
data sets or that kind of a thing. So we can put that on the next column. I'm just trying to think a better way to head it.
So there will be sample. Uh,
Method of obtaining sample, or that
okay,
wouldn't be.
we can't call it method of sample collection because they are not actually collecting sample.
No, they are not collecting it. Um, trying to think. So we know the type of smear, and now we are trying to explain the type of sample.
Can we call it sample generation method?
Sample generation method. Yeah, makes sense. Sample generation method.
Or method of
So
sample
yeah, no.
generation?
Sample generation method or method of still makes sense. And we'll have obtained from stored data sets and then
Yes,
obtained from
directly from patients.
directly from patients. Yeah,
So this one is obtained from um,
that stored data set.
okay, stored. Did I need to put the obtained from?
No, you can just put stored data sets.
Okay.
Okay. So if we go back to the article, let's now see the outcome measures. Our model produced F1 score of 94% to 96% with 10 of the 16 instances, producing F1 score of 95%. After averaging for all four datasets output by batch size, we observed that as batch size increased from 16 to 128, the average combined false positive plus false negative increased by 15.4%, and the average model F1 score accuracy decreased by the average training time. Yeah, I don't understand this Python analysis. So, in each data set, we observe a proximity. Let's go to their results, like in the main work, not the abstract. Okay. The four models with batch size 16, 32, 64. What do they mean by this batch size?
Before batch size,
Yeah.
like number of sample in each batch. So, but so
So,
this particular work, I think they are not really doing any form of microscopy here. I don't think I should have included this work.
they didn't do any microscopy.
Yes, they are just comparing different. I think they are comparing different computer-aided method without comparing it to normal microscopy.
So it was not compared to the conventional microscopy.
Yes, yes, they are comparing different type of computer-aided analysis.
Okay.
Mm.
So according to your eligibility criteria, should that be included or excluded?
It should be excluded.
And that means when you now exclude it, you will go back to your flow chart and put the reason for exclusion.
Okay, that means this one will be part of the ones I excluded during data
During
extraction,
full text. No,
during full
it will
test
be
reading.
full text reading, yeah.
Okay, sir.
What's the title again? Let
Of
me see
this
the title.
particular,
Hmm.
okay, let me go to the title.
Exploring the impact of batch size on deep learning. So they were more focused on the batch sizes.
Yes,
They are exploring the impact of batch size on deep learning artificial intelligence model for. Okay, so they want to know based on the batch size how the batch size will affect malaria detection. No wonder they are comparing 16,
yes, sir.
32. Okay, okay. No, this is different from what we have. I got confused. That's why I started asking.
Yes, sir.
So here, this thing is more on the how the batch size is going to affect the
Yes, the
detection of, yeah.
detection.
Yeah, so this is not what we are, this is not related to your this thing.
Yes,
So you will exclude it, and then I think the reason for exclusion for this now will be uh one, it didn't
the
compare,
contact with one. Okay.
it did not compare your the what was it called?
AI method was not compared.
The AI method with a conventional method.
Yes,
Because at least if it did and also looked at the impacts of the batch size, we could have considered including it because of that comparison.
yes, yes. But they didn't make mention of manual method. Anyway,
So, sorry?
I said they didn't mention manual microscopy at all.
No, no, no. Yeah, I didn't mention. So, and I think if I can remember clearly, one of your uh, inclusion criteria stated that it has to compare the conventional with the.
Yes, sir. You are correct, sir.
Yeah.
So I think I
Okay.
will
So,
this.
mm, do you have a folder you add the excluded work?
Yes.
Okay. Maybe because it is still open.
Yes, I want to close it first. So we can pick this next one. I should click the next
Okay.
article, abi?
Yes.
Okay.
Has he opened?
Okay, one now. I'm trying to minimize this one. Oh, when you are recording this. No, I don't know what's going on. Yes, no. Minimize for me now. So are you still there?
Yeah, I can't see your
Okay,
screen.
okay. Why now?
Thought you were still struggling with the laptop. Okay. Yeah, malaria parasite detection in thick blood smear microscopic image using modified YOLO V3 and YOLO V4 models. Manual, okay. Um,
So this one, we should copy the,
the surname of the first author.
yes. So is it always, the first author is always the main owner of the article, abi?
Yeah, and I think this work was in Ethiopia.
Okay, Sophia.
I think so, but we can double check.
No, this is Zoom.
What's happening?
Zoom. This guy. Who wants that?
So we'll now replace that first one. Okay. Let's go back to the work. Didn't even check the year.
It was 2021.
Okay, 2021, yeah. Let's go to the method. Their
This
method
one,
section.
they use data sets too.
Okay.
They use data sets.
And malaria blood smear.
Yes.
Okay. Can we go to their method?
Okay.
Is that the method?
Background.
This one is the background. From background, they just rush to result.
I think it's somewhere with this thing. So I see from this the method used.
The method in okay, they published the method in a different work.
Okay.
The method in 1920 used features extracted from patch-based CNN and classifies them using classical machine learning model such as SVM. For malaria parasite identification, patch-based CNN. I don't even know what the CNN is.
CNN is
For
convoluted neural network.
okay,
Yes,
for
neural
the
networks.
for the identification of malaria parasite from tick blood smear were proposed by the study by demonstrated the applicability of patch-based propose a patient level evaluation results using two different okay despite the success in their several okay go down. This study aims to investigate the applicability of state-of-the-art one-stage and two-stage object detection algorithm for detecting malaria parasites in microscopic image captured using smart camera. We propose malaria parasite detection in tick blood smear microscopic image using modified in this work. Let's go to the result. In this study, we have conducted experiments to evaluate the performance of state-of-the-art one-stage and two-stage deep learning-based object detection for detecting Plasmodium falciparum in thick blood smear microscopic images captured using a smartphone camera. Performance evaluation of the proposed model using mean average precision recall F1 score. This F1 score again.
It's a form of
Average
accuracy.
check.
Yes.
Okay. Average IOU and inference time in frame per second are done at object level. Performance analysis of modified yellow V3 and yellow V4 models. We have used so I think I don't even I'm trying to see where they explain what this yellow V3 and yellow V4 is. But from what I can pick, I think one of them is one stage and the other one is two stage deep learning based object detector.
Okay.
But I'm trying to if we go back to that introduction, maybe they will explain that yellow V3 and V4 better. Euro V3 and Euro V4 models, which are state-of-the-art objects in accuracy and speed, are not optimized for detecting small objects such as malaria parasites in microscopic image. We modify these models by increasing feature scale and adding more detection layer to enhance their capability of detecting small objects without notably decreasing detection speed. We propose one modified Euro V4 model called Euro V4 mode and two modified models of Euro V3 which are called Euro V3 Mode 1 and Mode 2. Besides, new anchor box sizes are generated using K-means clustering algorithm to exploit the potentials of this model in small object detection. The performance of the modified Eluvitrium V4 models were evaluated on a publicly available malaria dataset. These models have achieved state-of-the-art accuracy by exceeded performance of the original version, faster RCNN and SSD in terms of mean average precision, record precision F1 score and average. Lovit V4 mod has achieved the best detection accuracy among all the other methods with MAP of 96.32%. Have achieved. Okay. They demonstrate the performance of. So from what me I am understanding from this thing, this Euro V3 and Euro V4 initially were not designed for detecting small objects such as malaria parasites. So they modified it to be able to detect it, and now they are trying, but then they didn't mention like what they used to compare. Over the micro, okay, they compared because they said image captured by the smartphone over the microscope eyepiece. Okay. That's why I was looking for the method, because if we had the method, we would have had a better understanding of. Let me see their background of study.
But still, they didn't really compare.
So if you, what they said in the conclusion that
They just told
the
us
experimental
they only told us they use the automated method, which involve using smartphone to capture the image after the YOLO model have detected it. But they didn't compare the accuracy to normal method.
let me read their full background of study. Can you go down to their background of study?
Okay.
Not the abstract one. Yeah. Malaria is one of the leading public health burdens. Its prevalence is too high. So let me remove your name is okay. Its prevalence is too high in low income countries. In 2018 only, an estimated 228 million cases were recorded worldwide, and most of the cases were in Africa, comprising 93%, followed by Southeast Asia. Malaria is caused by a unicellular parasite. It is transmitted from infected person to depending on the severity of infection. Malaria is a curable disease, but lack of prompt and accurate diagnosis and treatment can cause serious health complications. However, the accuracy of microscopy-based diagnosis heavily depend on individual slide, reading experience, and alternativeness during diagnosis procedure. Besides shortage of well-trained in personnel imposes discrepancy on the effectiveness of microscopy-based diagnosis results in malaria endemic and resource-constrained areas, especially in rural parts of Africa. Inaccurate diagnosis results lead to mobility. An alternative, low-cost, fast and accurate computer-aided diagnosis is required. Can you scroll down, please? To overcome the drawbacks of manual microscopy-based diagnosis, okay? For the past 2 decades, a substantial number of studies have been collected to detect. For the past 2 decades, a substantial number of studies has been conducted to detect pathogens, including malaria parasites, from microscopic images. The three most commonly used methods to detect or classify malaria parasites in microscopic images of thick and thin blood films are traditional image processing algorithm, classical machine learning, and deep learning method. The traditional image processing technique mainly use rule-based classifiers and manually design low-level features such as texture, color, and shape using computational and complex image processing model. The performance of this method is low since manual design of optimal features extractor. Can you scroll down a little, please? Uh, where am I? The traditional image processing techniques mainly use rule-based classifiers and manually design low-level features such as texture, color, and shape using computational complex image processing method. The performance of this method is low since the manual design of optional feature extractor and classifier is difficult. Classical machine learning approach, which use manually extracted features such as inputs, were proposed for malaria parasite classification and detection. The proposed classifiers include support vector machine, linear discriminant classification, k-nearest neighbor, and the linear regression, Bayesian learning, and support vector machine, modified k-means clustering algorithm, feed-forward neural network, and deep belief network. The limitation of classical machine learning based techniques is either their inability to cope up with inherent variability of images from different domains since manually designed features extractor is suboptimal. Machine learning method based on handcrafted features achieve poor generalization capability in the classification task. Can you scroll down, please? No, like to the next paragraph. In recent years, deep learning based object detection and classification techniques have gained popularity because of their ability to overcome the limitation of traditional image processing technique, including classical machine learning algorithm. Deep learning algorithm can be applied to classify objects by taking image patches cropped from an input image using different pre pre pre-processing techniques such as segmentation of or sliding window technique. These techniques are computationally expansive due to massive number of patches generated and the application of convolutional operation for all patches to detect or classify malaria-infected cells. The method in 19 and 20 used features extracted from patch-based CNN and classified them using classical machine learning models such as SVM for malaria parasite identification, patch-based CNN model for the identification of malaria from tick bloodstream were proposed by 21 and to 24. The studies by 25 to 27 demonstrated the applicability of patch-based CNN model to classify malaria parasite from segmented thin blood smell. Discussed advantage of visualizing extracted features using deep learning method to better understand their learning strategy for classification of malaria. Propose a patient level evaluation result using two different. Can you scroll down?
Mr. Victor,
Yeah.
see, I want to make a suggestion. This topic, you know, the corona, what we see, what the corona,
Sorry, your voice is quite faint.
Eh? Okay, can you
Yeah,
hear me
I
now?
can hear you now.
Okay, can
Yeah.
you hear me now?
Mm. It has gone back to being faint again.
Hello? Hello?
Yeah,
Yeah,
I can hear you now.
you can hear me now, right? Okay. So I was
Yeah, yeah.
suggesting if we can switch topic to gamification so that we can learn the procedure well to save time, or we can get another work since this one is causing a lot of stress. You get?
Yeah.
We should even
But,
exclude this one so that we can save time a little bit. You get? So that we can just get the
okay,
basics and then maybe later we can now do a detailed read on it. Once we understand the procedure behind the process, you get, so that we not go stress you too much. Because this
but
one not they cause a lot of
the
headache. Oh, you should have was themselves.
the thing we say
Yeah.
each one we choose. The the fact is that you have to thoroughly read the work
Work.
for you to know what you are doing, which data you are extracting, and some of these things. So because if you don't thoroughly go through the work, you may miss out on some of the needed information. So usually, if I'm writing the proposal, I usually like try and guess what type of data I will be looking at that will help me with my final uh, narrative synthesis. If I'm looking at, maybe I want to compare the different ages of the people, the the type of exercise they did, where they did the exercise, whether it was home-based exercise program or uh, they did it in the hospital, those kind of a thing. So based on what you are looking at, sometimes you can think about what type of data you will be extracting at the end of the day. But this one now, because it's a new field, it's I'm finding it a bit difficult to kind of, except I get the information very well, then I can start thinking about what information I needed or not. But I think what we've been trying to look for here is to check whether they compared whether they use like the they compare their work with the conventional microscopy. For the fact that the method is not here, that's the major challenge. Because if the method was here, we could have gotten that information from the method section.
Let's
So
exclude this one.
I can say let's keep this one for now. Don't exclude it. Maybe at a later time when you have time,
Okay.
come back and then carefully screen
Yeah.
it to actually
Okay.
know whether. Mm.
Okay, sir.
Let's go to the next one.
I decided I want to do gamification.
Sorry?
So, Mr. Williams was suggesting gamification.
Since we started with this one, I think it will, like, let's just
Okay,
continue
sir.
with this one. Mm. Because if we want to swipe with to gamification, we start opening folders again, and
Yeah.
accurate. So let me see the title: Deep Learning Based Malaria Parasite Detection, Conventional Neural Network Model for Accurate Spatial Identification of. Okay.
This is the CNN they were talking about.
Yeah.
Okay.
Accurate malaria diagnosis with precision identification of plasmodium
I'm
is
looking
crucial.
for the dates and the location.
The year of publication.
Yes.
Uh, that's 2025.
You saw it where?
If you scroll down, that page, that footnote on the page where they said scientific result, scientific report, 2025.
Okay, I've
H.
seen it.
Mm, mm.
Then the location now.
The location, if you check on under the name, okay, School of System Engineering, Faculty of Engineering,
Venezuela.
Venezuela. Yeah.
This article is 2025.
Uh, they use blood smear. Then let's see their method.
Okay.
Why are all of them just rushing to results and discussion?
This one too. Okay. This method.
Okay.
So they use
This
data set.
study utilized a data set comprising micro. Okay. Yeah, so they use data set.
Okay, I think I've included that already.
Mm. The data set is actually from Bang, Bangladesh. I be Bangladesh.
Bangladesh.
Yeah, but let's just check. The image were captured through the eyepiece of a microscope. Okay. All images were saved in the RGB. Okay. Another unit in Bangkok. To ensure the model's effectiveness and accuracy. Okay. If you scroll up, scroll up again. Okay. If you go back to that your table,
Okay.
so one thing I've picked up is that for each of them, they they use these algorithms.
Okay.
So under the, I think we can create another column after outcome measure. After, yeah,
Mm.
yeah. Why is it going there? Okay, straighten that one as the result. So if you put it on the left, this thing is not where. Uh-huh. Type, type of algorithm. Okay. So for this particular one, they used blood smear and they used stored data set. The outcome measures, they were comparing P falciparum, detection of P falciparum and the P vivax using what was the name of that this thing they used again?
Yeah, Nina.
Yeah, CNN. So we can pick up those types of algorithm from the work, the ones they used. If you scroll up a little. Sorry, I mean like if you go up, not scroll. Not this side. Go down to that method. Okay, scroll down again. So these are the algorithm that we're using. The Is it called Kami edge detection algorithm? Have you seen it?
Okay. Yes.
So the result will be, if you go to the result section, what I do sometimes is I will just copy the result from the abstract, because the result from the abstract is like a summary of the results from the work. Can you go to the abstract?
Abstracts.
Yeah.
This is the abstract.
Yeah. So this one is the condensed abstract. Let's check where the result is.
So the result is starting from the model accuracy.
Okay.
Sir? Mr. Victor.
Best performing. I can hear you.